Hi guys, and today's video is about the complex numbers and its other forms. The first problem is the jth root of negative j, which is equal to negative j raised to 1 over j, simplifying the exponent by multiplying 1, that is 1 over j times j over j, that is j over j squared. And the value for j squared is just negative 1. So j divided by negative 1 is equal to negative j. So it is much easier to solve with negative j raised to negative j. We can use a different property, that is e raised to ln of x is equal to x. With our x being the negative j, we can make it 2e raised to ln of negative j raised to the power of negative j. By the rule of exponents, raising an exponent by an exponent, that is multiplying the both exponents, e raised to ln of negative j times negative j, which is equal to, by the way, the corresponding value for ln of negative j, that is just negative j pi over 2. Next, we substitute the value, gives us e raised to negative j pi over 2 multiplied to negative j. Now, multiplying negative j by negative j gives us j squared, and j squared is equal to negative 1. Negative 1 multiplied to pi over 2, that is negative pi over 2. Our final answer is e raised to negative pi over 2. For our second problem, it is evaluate log of negative 5. This is just the solution for real, but this is complex. We will make it logarithm of negative 1 times 5. Using the property, that is logarithm of negative 1 plus logarithm of 5. But the logarithm of 1 has a corresponding value from the property of e raised to j pi, which is equal to negative 1, getting the logarithm, that is logarithm of 1 of negative 1 is equals to j pi. Substituting, that is j pi plus logarithm of 5, which is also equal to 0.70 plus j pi. Third problem, we have the ln of 1 minus j square root of 3 raised to 3. First, we have to convert the 1 minus j square root of 3 to its exponential form. So we must get the r and the theta. We can use a calculator for getting the values. For manual calculation, we just use the Pythagorean theorem for r and the angle, which is r tan y over x. But in the exponential form, we need to use radians, so that the angle would be multiplied to pi over 180. So that gives us r of 2 and a theta in radians, which is negative 1.05 radians. Then we have our exponential form, that is z is equal to ln of 2 e raised to negative j 1.05. Don't forget the exponent of 3. So it is equal to 3 times ln of 2e raised to negative j 1.05. We just used the property, which is the exponent will be transferred, will be multiplied to the ln. So the ln part is equals to the ln of 2 minus j 1.05. So it was ln e, so we cancel that, so it is equal to 1. That's why the remaining is negative j 1.05. So the answer would be 2.08 minus j 3.15. On to our last problem. We have the logarithm with a base of 1 minus j of 1 plus j square root of 3. That corresponds to the log b. That corresponds to the log of z with a base b, which is equal to just the ln of z over ln of the base. Now we substitute, that is ln of 1 plus j square root of 3 over ln of 1 minus j, that is the base. Now we need to convert the numerator and denominator. We need to find the r and the theta, which is in radians. We can use a calculator to determine those values. That is 1 plus j square root of 3 in its exponential form, that is 2 e raised to j 1.04. Rounding up, that is 1.05. 1.05. Now, to the denominator, that is ln of the exponential form of 1 minus j. My calculator is already in radians, so that is 1.41 e raised to negative j 0.79. Now we use the property of logarithms, that is ln of 2 plus ln e raised to j 1.05, that is just j 1.05, and the ln of 1.41 minus the j 0.79. Now we can determine the value by using the calculator. Ln of 2 plus j 1.05 divided by ln of 1.41 minus j 0.79, and the answer is negative 0.79, or the round off 0.80 plus j 1.22. Our final answer would be negative 0.8 plus j 1.22. Today, I learned the roots and the logarithm of the complex numbers, plus its properties of the logarithm and the value of complex number raised to another complex number.